And we're back. Okay, we are looking at number 2 on this class kick. We have quadrilateral QUAD is similar to quadrilateral SIML. Now notice that it's hard to tell what's going on in terms of reflection and rotation and things like that because it's Q corresponds to S, U corresponds to I, A corresponds to M, and D corresponds to L. Okay? So it's a little counterintuitive how it's drawn. You just need to be careful with that. We want to remember to trust the similarity statement about what corresponds to what. Okay, so I'm going to write the similarity ratios up here just like we did for number 1. QU corresponds to SI. So I'm going to write QU over SI. That ratio is going to be equal to UA over IM. UA over IM. And that ratio is going to equal to AD over ML. AD over ML. And finally, the last ratio is DQ over LS. DQ over LS. All of those ratios are going to remain true since these two quadrilaterals are similar. Okay, so which ones do I have a pair for? It looks like I have a pair for QU and SI. Okay, I have these two numbers. I know it initially doesn't look like they correspond, but according to this they do. So QU over SI is 20 over 8. Okay, and that is not an integer, but that's okay. Now we could simplify that if we wanted to, right? That's the same as 4 times 5 over 4 times 2, and 4 over 4 is equal to 1, so that's 5 over 2. Okay, so that's the ratio between the bigger one and the smaller one, is 5 to 2. Alright, so I'm going to use 5 to 2 there. And I'm going to say, I'm going to solve for MI here, or IM. Alright, so I have 5 over 2 equals UA over IM. Now let's see, I have UA is 25, and I don't have IM right there. So I'm going to just write IM. Okay? So the idea here is I want to go from here to here. I want to go from 25 to IM. 25 times what is IM, right? So I can do this here. 5 times what is 2. A little bit hard to think about what that is off the top of your head, although maybe you can. But you can also just do an algebra problem with that. 5 times what is 2, right? 5 times what is 2. We could have done it with this. 20 times what is 8, and we get the same answer. So to solve for x, divide both sides by 5. X is 2 over 5. So 5 times 2 over 5. 5 times 2 over 5 is 2. So 25 times 2 over 5 is what IM is. So 25 times 2 over 5 is IM. Alright? So I need to solve this. 25 is the same as 25 over 1. So I'm gonna actually break this down. Rather than doing 25 times 2, I'm going to break this down to 5 times 5 times 2 over 1 times 5 is 5. Right? And the reason why I do that is because then it's easier to see that I can simplify 5 over 5, which is 1. And so I have 2 times 5 is 10. Okay? So I can see that IM is 10. IM is 10 right there. I'm going to circle that in red. Okay? IM is 10. Okay? Now, let's see. What's the other thing we need? We need SL. We need this one here. Okay? So we have DQ. It's 13. Alright, so I'm going to use this same ratio. Again, we could use 20 over 5, 20 over 8, but I simplified it to 5 over 2, so I like to use the smaller numbers. Okay, so I'm going to say that 5 over 2, okay, it's the same as 20 over 8, 5 over 2, right, is equal to dq over ls, right? So that's going to be 13, dq is 13 over ls, and I don't know what ls is, so I'm going to write ls. Okay, and in the same way, we want to go, but this time we want to go the other way. No, we want to go this way, sorry, excuse me. We want to go the same way. 13 times what, right? We have the same processes over here, so again, 5 times what is 2? 5 times 2 over 5 is 2. So 13 times 2 over 5 is ls. Okay, and again, you don't have to solve these proportions this way. In the description, I'll link to my proportion video, and I give a few different ways to solve this. You could solve it a few different ways, but you'll get the same answer. So 13 times 2 over 5 is ls. So 13 times 2 over 5, right, is ls. Okay, and in this case I can't simplify anything, so I'm just going to multiply it out. 26 over 5. So ls is 26 over 5. I'll write that there. Okay, ls or SL, 26 over 5. Okay, and I'm going to circle that in purple, if you can see that. Okay. Now, we also have some angles here, and we're going to figure out those angles. Now, there's an idea here that actually in my classes I think I did not talk about, or at least I didn't emphasize. I think Mr. K probably has done that. But we want to talk about how many degrees the inside of a quadrilateral has. Now, before we do that, let's fill in what we know. Q corresponds to S. We know what Q is, and that corresponds to S. Q is 75, so that means S must also be 75 degrees. Okay? Now, U corresponds to I. U corresponds to I. I is 85, so U must be 85 degrees, right there. And I can fill that in right there. Okay? U is 85 degrees. Awesome. A corresponds to M. A corresponds to M. We don't have either of those, so we'll have to come back to that. And then D corresponds to L. D corresponds to L. We have that one. That's 120. Alright? So I can write that in right there. 120. So we need to figure out what A is here. Alright? And we have a quadrilateral. Okay? Now, something that Mr. K probably talked about, but I don't think I did for my classes. In a quadrilateral, we always know how many degrees a quadrilateral has. So, I drew a few quadrilaterals here. If you'll notice, I can take any quadrilateral, go from two vertices, and make two triangles. And we do remember that the interior angles, okay, of triangles add up to 180 degrees. So if I had, say, x degrees here, y degrees here, and z degrees here, x plus y plus z would be 180 degrees. And then let's say over here I had a degrees, b degrees, and c degrees. Well, a plus b plus c is 180 degrees as well, right? But all four of the quadrilateral angles, given that this angle is z plus c and this angle is x plus b, all four of these angles is just these 6 angles all added up together. So that means that this quadrilateral must add up to 3, this is 180 over here, but the whole thing is 360. Okay, so any quadrilateral you can always break up into triangles. And since this is 180 and this is 180, the interior angles add up to 180, that means the whole thing adds up to 360. The whole thing, all the interior angles of any quadrilateral are going to add up to 360. And frankly, just in case you care, any sort of, say, any polygon. This would be a hexagon, right? 1, 2, 3, 4, 5, 6. You can do the same thing. You can break it up, okay, into triangles, right? And each one of these is 180. So this would be 4 triangles, 4 times 180. So all hexagons add up to 720. Kind of a cool little thing. So we're going to go back to this. We just learned that all quadrilaterals add up to 360 degrees, and I have 3 of these angles, but I want the 4th one, angle A. So I have these 3. I got 120 degrees plus 75 degrees plus 85 degrees. I'm going to put here plus A. Measurement of angle A equals 360 degrees. Okay, I ran out of room. I should have written that differently. So I'm going to combine these here, right? I have measurement of angle A plus, right? This is 160, so I'm going to say 120 plus 160 equals 360. I have measurement of angle A equals, what is that? 280, excuse me, plus 280 equals 360. Right? I'm going to minus 280 from both sides. And I have measurement of angle A equals, that is 80 degrees. Okay? I have 80 degrees there, I have 80 degrees there, and I have finished all that has been asked of me. I hope that was helpful. We will see you next time.